Hello everybody and welcome to this Git/GitHub tutorial. In this video, I'm going to be showing you everything you need to know about Git/GitHub to get started as fast as possible. Now, yes, this video is fairly long, but it's because I really want to make sure you understand how Git and GitHub work, the differences between them, and what these commands actually do. With that said, what I'm going to be covering here is initializing a local repository. I'm going to be talking about tracked files, untracked files, staged changes, and unstaged changes, as well as branches, remote repositories, and all of those other things that you just really need to know and are fundamental to Git and GitHub. After this video, you should be comfortable using these two tools, and in any kind of industry environment, you're probably going to know about 90% of the commands that you need to. So anyways, let's get into the video after a quick word from our sponsor. Before we dive in, I need to thank CodeCloud for sponsoring this video and talk to you about an awesome platform called CodeCloud Engineer. CodeCloud Engineer is an all-in-one platform designed to make you an expert in DevOps technology, and the best part is that it is completely free. Once you register on CodeCloud Engineer, you will start working as a systems administrator at a fictional company and move up in the ranks as you gain experience. As you complete tasks related to Bash, Linux, networking, CI/CD, and many other DevOps-related topics, you'll be promoted to a DevOps engineer, senior DevOps engineer, and finally a DevOps architect. This structure allows you to simulate what it's actually like to work as a DevOps engineer at different levels and develop the necessary skills you need. CodeCloud has hundreds of tasks, explanation videos, and 3 large projects you can complete. You'll start basic by learning about Linux, Bash, and common commands, and move into working with databases, system design, and much more. If you have any trouble doing your tasks, you can ask other engineers for help or request a review of your work. CodeCloud Engineer has over 3,600 engineers on the platform, many of which have landed jobs at tech companies like Dell, Apple, Google, Microsoft, and many others. Get started today for free by signing up from the link in the description. So we'll get into the commands in one moment, but I want to quickly describe the difference between Git and GitHub. So when we talk about Git, we're talking about the actual version control software. Now, typically Git is ran as a command line tool and it's ran locally on your machine. This is the software that we're actually going to install before we get into all of the commands. Now, what Git does is it allows you to track your code and version history. It allows you to work on different versions or different branches of a code base, and it helps everybody synchronize their different versions of code. So say a local repository versus a remote repository. How do you sync those repositories together? Well, you can use Git to do that. Now, this differs from GitHub. These are two separate things. GitHub is a web application or a website that hosts remote Git repositories. It's owned by Microsoft and it's deeply integrated with Git. And really what it does is it just provides extra functionality on top of Git and kind of a nice user interface to use Git on. Now, GitHub is usually used by teams of 2 or more people. The reason for this is that when you have a remote repository, anyone can access this repository from anywhere around the world. And so that would be kind of where your main code base lives. And then all of your developers would have a copy of this code base on their local machine, so a local Git repository. And then when they make changes locally, they would push those changes up to the remote repository that's hosted on GitHub. So those are kind of the differences between Git and GitHub. Of course, there's a lot more, but just understand that because Git and GitHub are different. And really what I'm going to be covering here is Git, although I will show you how we can host a remote GitHub repository. So I figured I would include this step in case any of you haven't already done this. You do need to install Git. So to do that, you need to download Git from this website. I'll leave a link in the description. Choose the appropriate version, Mac, Windows, or Linux, and then run the installer with the default options. You obviously can change them if you want. The default is totally fine. And then you'll be ready to follow along with this tutorial. So now that we've installed Git, we can actually create our first Git repository. What we're going to be doing is initializing what's known as a local repository. This differs from a remote repository because a local repository lives on your local machine, on your actual file system, whereas a remote repository would live somewhere like GitHub. Anyways, the command to initialize an empty Git repository is git init. Now, don't type this in yet or don't press enter yet until you've changed the directory of your command prompt or terminal to be in the folder where you want to initialize this repository for. Now, a repository is really just like a project, just like you may have a folder that stores all of the information or all of the code relating to a website. Well, you would have a Git repository that has all of the files related to that website. So what I've actually done is I've created a folder here on my desktop. It's called Git Demo. I've opened it up here inside of Sublime Text. This is just a lightweight code editor that I like to use for videos. You can download it from the link in the description. Anyways, you don't need this, but what you do need to do is open up your command prompt or terminal. You will likely be in your home folder when you first open this, and you need to navigate to the folder or directory you want to initialize this repository for. Please do not initialize a repository in your home folder. That means all of the files in your home folder, including all of the subdirectories, will be a part of that Git repository, which is just not ideal, and you do not want to have that. So what you're going to do is go cd and then change directory to whatever location you need to go to. In this case, I'm going to go to my desktop, and then I'm going to go to my Git demo folder. Now, here's a little shortcut for you guys. If you are on Windows, what you can do is actually use the regular file explorer to navigate to your folder. You can see I have Git demo open right here. You can go inside of this address bar here and type cmd, and then it will actually open up a command prompt that is in that location. You can check that by looking at the path right here that's showing up. So now that I'm inside of this folder right here in my command prompt, what I'm going to type is git init and press enter. This will initialize an empty Git repository. It shows you the path that initializes it in, and you can see that what it actually does is create an empty folder called .git. This folder indicates that everywhere inside of this directory is a part of this Git repository. And if you open up this folder here, you can see a bunch of information relating to the repository. Now, the reason I'm able to see this folder, and many of you won't see it, is because I have hidden items showing in my file explorer. If I uncheck that, you see it goes away. So it is actually a hidden folder. The way you can see it, if you're on Windows at least, is you can check hidden items. If you're on Mac, I believe you can right click in the Finder and there's something that shows hidden items, although I may be incorrect about that. Anyways, you don't have to worry about this folder, but if you wanted to delete this Git repository, you would need to delete this folder. So you would just delete it like that. Don't worry, that won't delete any of your files. It will just delete the information relating to the versions of all of those files. Now, it's worth noting that you can initialize a Git repository in a directory where files already exist or where there's already code written. That's totally fine. All that means is that anything that you've done before you initialize the repository will not be tracked by Git. So the version control, the version history of that, will not be tracked by Git because, well, Git wasn't tracking it when you originally wrote that code. So now that we've initialized our first Git repository, it's a good time to discuss tracked versus untracked files and then the staging area in Git. Now, first, I must correct myself. Previously, I was saying that wherever you initialized a Git repository, all of the files that were in that directory would automatically be a part of that repository. That is incorrect. You actually need to manually add files to the Git repository, which I will show you now. So when we're talking about Git, we have this thing called the staging area. We have this concept of tracked and untracked files. Right now I have 3 files here, and these 3 files currently are being untracked. You can see as I highlight these little bubbles in Sublime Text, it's saying untracked. What that means is that Git is currently not keeping track of these files. So any changes that I make to these files, Git does not care about, it's not saving, it doesn't know, because we have not added these files to what's known as the staging area and started tracking them. Now, the way that you can see if you have any untracked files is you type Git Status in your command line here. So when you type Git Status, it will tell you a bunch of information, some of which is not really relevant right now, but notice it says untracked files and it shows us these 3 files right here. So this means that if I do make a commit right now, which I'll discuss what that is, these 3 files will not be a part of it. So now let's briefly discuss commits and kind of the workflow in Git. So in Git, we have 3 main areas. We have our local area, we have the staging area, and then we have a commit or the actual repository. So when we're discussing our local area, that's stuff that you see. That's stuff that's on your file system. These 3 files here, even though they're not a part of the Git repository, they do live on our file system. They're in our kind of local file area, whatever you want to call it. Then we have a staging area. What the staging area is a temporary area that allows you to decide what files and what changes you want to be a part of a commit. So if I wanted these files to be tracked by Git, I would add them to the staging area, and then I would make a commit. Now, what a commit is kind of a bundle of changes. So I like to think of a commit as a checkpoint. Every time you do something significant in Git, you should make a commit. So if you fix a bug, if you implement a new feature, if you refactor some code, anything that you'd want to potentially go back to in the future, you would kind of bundle all of those changes in a commit. And what the commit is kind of a little dot on a timeline. At least that's the way I like to think of it. So whenever you make a commit, Git is actually storing that information. And so you're able to go back to that. If you say mess something up in the future, you can go back to a previous commit. However, anything that you do not commit, so any changes in between two commits, you cannot get back to. You can only get back to the state at a commit. So hopefully that makes sense, but you go from your local area to the staging area to a commit. All of those commits are actually stored in the Git repository, and that's kind of the point of the repository, is to keep track of the version of code, but you have to define what versions you want to store by creating commits at whatever point makes sense for you. So now let me show you how we add these files to the staging area. So the command to add them is git add. If you want to add all of them, you type git add dot. If you want to add individual files, you type git add and the name of the file. So I'm going to add another .py to the staging area. And if I type git status, now it's going to tell me that I have some changes that are ready to be committed. What that means is this file now is being tracked by Git because it's been added to the staging area. However, these two files are untracked and not staged. So I'm going to add another one. I'm going to say git add and then test.py. And then if we look at git status, we now have two files that are in the staging area and that are ready to be committed, whereas this one is still not tracked. Now, to remove a file from the staging area, what you can do is type git rm -- cached, then the name of the file. So let's do test.py. And now if you look at git status, you can see it is untracked. So let's add that one back in though, test.py, git status. All right, so now let me show you how we actually make a commit and what's gonna happen here when we have these two files in the staging area and this one is not. So to make a commit, what you do is you type git commit -m. That stands for message, and then you list the message that is associated with this commit afterwards. Now, whenever you write a commit message, it should be in present tense, it should be relatively short, and it should accurately describe in as few words as possible what the changes are that you made. The reason for this is that when you're looking at commits later on and you need to roll back your code to something previous, you want to actually be able to, figure out what you did in what commit. If you're just typing, commit 1, commit 2, commit 3, that's not very helpful. So here I'm just going to say first commit. This is valid because, well, this is actually our first commit, but going forward, I will want to describe the actual changes I made. So like, fix this bug, implemented this feature, so on and so forth. All right, so we type that in. Now we can see we have 2 files changed, 3 insertions. That's just the number of lines that we actually inserted. And then it gives us some information saying that we created 2 brand new files. Notice though, there's no information relating to this not tracked file because, well, it's not tracked. So if I type git status, what you can see is this file still is not tracked. All right, so now let me make a change to this file here. So let's delete this line, print test. And now what I'm going to do is type git status. Now, when I type git status, notice we have changes not staged for commit, and then we have untracked files. So by default, any of the files that were associated with the last commit are being tracked by Git. So any files that existed in the previous commit or the most recent commit in your repository, they're being tracked. So any changes that you make to them, Git is able to detect. We can see that because it's telling us that we've modified this test.py file, even though I haven't manually added this to the staging area. And that's simply because it's being tracked. However, this change has not been staged. So again, there's kind of a difference. We have tracked files and then we have staged changes or staged files. So this tells us that that change we made to test.py is not staged. So this means that if I decide to make a commit now, this modification will not actually be included in this commit because I've not staged that change. So whenever you make a commit, it's only things that are staged that will be a part of it. So to actually stage this, what you need to do is re-add this file to the staging area. You type git add and then test.py. And now if I type git status, it's green because we've actually now staged this change. So now if I decide to make a commit and I say, changed, and we can just say test.py, then that will actually be a part of the commit. We have 1 file changed, 1 insertion. All right, so let me just show you a few more examples here. I'm going to make a change to not tracked. I'm just going to say console.log, and we'll just log test like that, my semicolon. And again, notice here now, if I type git status, still not being tracked. And now if I try to make a commit, so git commit -m, and I say, JS or something, nothing's going to happen. The reason nothing happens and we get this message is because I didn't make any changes, and well, there is just nothing to commit. All right, so hopefully that is clear, but that is how you make commits. That is kind of the staging area and tracked versus untracked files. Now what I'm going to talk to you about is branches. So what a branch is really a variation of the code base. Now I would like to say version of the code base, but that has a little bit of a different meaning. So I think variation is a better way to describe it. But essentially the point of branches is that you can kind of have a branch that is, say, your master branch. And the master branch is where all of your production level code is. That's where stuff that's been tested, that has been code reviewed, and all of that is kind of going to be sitting and living. So you're 100% sure that all of that code is perfect, clean, and up to standard. Whereas you may have some other branches where you're, say, working on a feature, or you're doing something that's not yet quite finished, and that you don't want to be living in, say, the master code base that all of your other developers are looking at. You want it to be kind of off to the side so that a few people can work on it without interfering with the main code base. So hopefully that makes sense. But what you can actually do with branches is you can branch off from other branches. So you have one main branch, and you would have seen this when I typed Git Status. It says we're on the master branch. So the master branch is your standard default branch, and then what you can do is branch off of that branch. So we'll be at right now a certain commit, right? At this point in time, the last commit is kind of the commit that this branch is at. And so if I decide to create a new branch, I will make a copy of this master branch at this point in time. So whatever the last commit had on it will be what is on the new branch. And then once I go on that new branch, I can make commits to that branch without affecting the master branch. So it's easier just to see this with an example, but to go to a new branch, you type git checkout -b and then the name of the branch. -b just stands for new branch. So what I'm going to type now is, let's say, I don't know, new -feature is our branch name. And now I've switched to a new branch, new feature. So now what I can do is make some changes on this branch. So let's just, print test a few times here. Let's save this. And just like we would do in a regular Git repository, like we've done before, so we're going to add this change to the staging area. So git add and then another .py. And it's worth noting that if you just want to add all files to the staging area, you can type git add dot. This will add everything in this directory to the staging area, including this not tracked file here. So now if I type git status, you can see that this not tracked file, new file, and another .py has been modified. And now what I can do is make a commit. So I can say git commit -m, and I can say new feature on new branch or something. It doesn't really matter what I'm typing here because this is just an example. But again, usually you want to make these descriptive. All right, so now I have 2 files changed, 3 insertions, and notice that I have kind of these 2 test things inside of here, right? Or I'm printing test 3 times, sorry. So now what happens if I go back to the master branch? So I've made a commit on this branch, and this commit does not affect my master branch. So to get back to the master branch, you can type git checkout and then the name of the branch that you want to move to. So when I type git checkout master, you're going to notice that this file now changes. Why does this file change? Well, the reason it changes is because the commit that I made on the previous branch didn't affect this branch. So any changes there did not affect what was here. And notice that this not tracked.js file actually was deleted when I switched back over to the master branch, because right now it only lives on that other branch. Now, this is kind of a little bit of strange behavior. Some of you may be wondering why this happens, but if you don't add a file to the branch and then you add it to a secondary branch and then you swap back to the master branch, well, it deletes that file because that's the change in the 2 branches. But since it was on that last branch that we were on, so that new feature branch, but it's not on the master branch, Git just removes it when we check out the master branch. So anyways, I'm just going to remove this right here, but then I'll show you if I go back to new feature, so git checkout new feature, then now that file is going to show up again. You could see not tracked.js shows up, and now another .py has those changes I made on the previous branch. So this branch is what's known as one commit ahead of the master branch. The reason it's one commit ahead of the master branch is because if we're comparing it to the master branch, there's one commit on this branch that does not exist on the master branch. So that is really the basics of branches, and you can kind of branch out as many times as you want. So from this branch, I can create a new branch. I can say git checkout -b. I can say, extended or something, call it whatever you want. And now on this branch, I can make any changes that I want. So maybe I go in test.py and maybe I just print hello world a bunch of times and I save that, and maybe I even delete a file, right? Maybe I delete this not tracked file, so we'll delete that file. And then I add all of this stuff to the staging area and I make a commit. So git commit -m, or sorry, just m not am. I'm gonna say removed file and changed test.py. And then what I can do now is go back to the previous branch, and you'll see that this will not have affected that. So if I say git checkout new -feature, oops, I have to spell checkout correctly. So git checkout new feature, then what you're going to see is, well, we get this file back, test.py goes back to normal, another.py is what it's at. And then I can even check back out to the master branch. So git checkout master. And then from the master branch, I could even check out extended, right? And then I go back there. So that's how the checkout command works. Now, if you want to view all of the branches that you have, you can type git branch. This will show you all of them. And the asterisk one is the one that you are currently on. And yeah, that is kind of the basics of branches. So now what I can show you is what's known as merging branches. Now, this is where it gets a little bit complicated, but the idea is that we've made some changes on a branch, right? Now these changes are good. We've tested them. We're ready to say, put them into the master branch. Well, how do we go about doing that? Well, what we need to do is merge these two branches together. Specifically, we're going to take all of the commits on, say, this extended branch or whatever branch it is that we want to merge, and we're going to overlay them or kind of lie them down onto the master branch. So it's hard to maybe visualize this, but we're taking all the commits on one of these branches that are different than this master branch and kind of adding them in and trying to, combine these two branches together. So what I'm going to do is I'm going to type git merge, and then I can type the name of the branch that I want to merge with the existing branch. However, I don't really want to merge anything on the extended branch. What I want to do is actually go to the master branch and then take the work that I've done on the extended branch and bring that to the master branch. So I can say git checkout master, and then I can type git merge extended. Now, what this is going to do is take all of the work from the extended branch and just overlay it onto this branch. So now I'm going to have this another.py. I'm going to have this test.py. I'm going to have all that work here. And there we go. Okay, so that's all great, but now what I want to show you is what's known as a merge conflict, which happens all of the time, is really annoying, and you definitely need to know how to fix. So a merge conflict arises when you try to combine two branches together that have conflicting changes. Now, it's best just to show you this with an example. Let's say that I actually change this text here to say text, and I change this to maybe say Tim is great. And then I want to make a commit. So I can say git add dot, although I'm going to show you a little shortcut here. If you want to make a commit and just add everything from the current directory to that commit, you can type git commit -am and then the message. So this means like add everything and then the message. So the message in this case is going to be just test. Okay. So I've now made this commit. Notice that I didn't have to add anything before that because I added the A. Now what I'm going to do is git checkout the extended branch. And now that I'm on the extended branch, I'm going to make a change. So here we have hello world or something. So I'm going to change this line to just be an empty string. I'm going to say git commit -am, and I'll just say modify test.py. Okay, so now I'm going to go back to my master branch. So git checkout master. We should see this file change in 1 second. Yes, it does. And now I'm going to merge the extended branch with this master branch. So I'm going to say git merge extended like that. Now, when I do this, notice that I get a conflict. It says auto merging test.py, conflict content, merge conflict in test.py, automatic merge failed, fix conflicts, and commit the result. So you can see we're getting a little thing here, and it's saying that we have a conflict. And notice that now in this file, it actually shows us the version of our current branch and then the version of the extended branch. And so what we now need to do is fix this conflict. So to fix this conflict, what you need to do is just modify the file so it's what you want it to look like. So what we can do is say, all right, do I want the changes from this current branch? Do I want the changes from the extended branch? Or do I want a combination of both? Now, what I can do is just delete this. I also could leave this in if I want. I don't have to remove that. And then I'm going to save this file. So once I've kind of fixed those changes, then what I do now is I continue this merge. Okay, so now that I fix this conflict, what I do is I commit the result. So this is what's known as a merge commit. So I can say git commit -m, and I can just say merge extended. Okay, so I realized I first need to add these files to the staging area. Sorry, so I'm just going to type git commit -am, merge extended, and then we are all good. Now notice it's not telling me there was any insertions or deletions. The reason for that is because this was a commit simply to fix that merge conflict that we had. So now the last thing that I need to show you is remote repositories. So what I'm going to do is open up GitHub, and I'm going to create a new remote repository and be right back. So now we've discussed most of the core commands in Git that you need to know. Of course, there's many more, and I welcome you to look them up on your own. However, we're going to talk about remote repositories now. So I'm on GitHub. You do need to make an account for this to work. And what we're going to do is create a new repository. So go and press this plus button up here, and you can either import a repository, do all this kind of stuff, or create a new one, which is what we're going to do. So we're going to input the name here. The name can be whatever. I'm just going to call this test repo, and then obviously it'd be a good idea to put a description. You make this public or private. I'll just make mine public for right now. And then you have some options right here. So if you are going to be importing an existing repository, you don't want to select any of these. Now, what that means is you've already worked on some code on your machine. You're not starting completely from scratch, and you want to actually upload that code to GitHub. Then you wouldn't select any of these. However, if this is the first time you're kind of creating any repo whatsoever, you would check one of these, and I'll kind of go through both options with you in a second. But for now, we're not going to press these because we want to take the code that we have on our machine and kind of upload it to GitHub. So now I'm going to press create repository. All right, so now you can see some instructions are showing up on the screen on how we can actually upload our repository here. Now there's a few different ways to do this. I'm going to show you the simplest way. So notice it's kind of assuming here that we haven't already initialized a repository. So it's telling us, git init, git add, readme, git commit. We've already done all of that. And then what this actually does, git branch -m main, is it renames the branch, our master branch, to main. Now the reason for this is GitHub has recently changed master to main. I won't go through the reasons behind why they did that. But anyways, on our local machine, our main branch is called master, and so we must rename it to main. So kind of these three steps here are what we need to follow along with. The important thing is that you take this URL. If you grab this URL here, so whatever your kind of username is, and then the name of the repo, then you don't need to reference this page anymore. I'll show you how we can do this. So what I'm going to do now is I'm going to go here to my kind of terminal, and I'm going to start by renaming my master branch to main. So to do that, I'm going to say git branch, and first I actually need to make sure I'm on the master branch. So I'm going to say git checkout master. I'm already on master. That's good. Okay. So now I'm going to rename it. So git branch -m main. I've now renamed this branch. So now if I type git branch like that, you can see this is now called main. All right, now what I need to do is add what's known as the remote repository as kind of a URL to this repository. So this line right here is what you're going to want to copy, git remote add origin. I'll just type it out, git remote add origin. Now what this is saying is, okay, remote, we want to add a location for a remote repository. You can have multiple of these, by the way. You don't only have to have one. And this is the name of that location. So let's say you had like 5 or 6 different servers, or you had different GitHub repositories or something, and you wanted to potentially push to multiple of them. When I say push, I just mean take the code locally and push it to those different repositories, like upload it essentially to them. And then you could add different remote locations, but git remote add, the name of the location. You can call this whatever you want, but origin is kind of the standard, and then space, and then you're putting the actual URL for that remote location, which is, well, this, and yours is going to be different. So I'm going to press enter. Now it's going to add this as a remote. If you type git remote, you should actually see all of the ones you have. In this case, we just have origin. So now all we need to do is type git push -u origin master. Now what the -u stands for is remember these settings. And so git push is saying, all right, let's take all of this code that's local and let's put this somewhere else. So when I say git push -u, it's saying, all right, we'll save the options I'm going to put here. You then say where you actually want to push this code to and what branch you want to push it to. So in this case, I'm taking the origin, that's where I want to send all of my local code to, and I'm pushing the main branch. So now if I type git push -u origin main and I press enter, it's going to take a second. We will see that, some loading stuff is happening here. And then if we actually go and refresh this page, we're going to see that all of our code is now here. We have another .py and test.py on the main branch. Now what we can do though is we can push up multiple branches, right? So if I go to a different branch, so I say git checkout, and let's just go to the extended branch like that, I can actually push this branch again to the origin. So I can say git and then I guess push origin, and then I can choose the extended branch. And now what this will do is push the extended branch. So now if I actually refresh this here, I can look at this little option here. I can see that there's now another branch called extended. And in this branch, I will see some different things. So hopefully that is clear, but that is how you push something up to a remote repository. Now, sometimes other people will be pushing to a remote repository as well, and your branch on your local machine may become outdated. For example, let's say we decide to add a README here to the main branch. I'm just gonna keep it with a title that says test README. So I've just added that here from the actual GitHub user interface, and now this branch has one commit that is ahead of this branch right here. So if I go ahead and git checkout main, notice this says your branch is up to date with origin master. That's actually not correct, because now if I use the command git pull, what this is actually going to do is pull all of the changes from the remote repository and update my local branch with those changes. So here we now got a README file, and now if I come and look here, we can see that this README file does actually exist. So hopefully that's kind of clear, but if you want to get changes from the remote repository, you use git pull. That will then update your local branch with those changes. All right, so now that we've covered that, the last thing I want to show you is what is known as the Git Clone command. So if you go to any kind of remote repository and you press this code button here, you'll see that there is a URL. If you copy this URL, you can actually clone this repository to your local machine. So in fact, let's go to like a Microsoft repository, Microsoft VS Code, GitHub, and I'll show you something that's not mine. So here we go, we have Microsoft VS Code. I'm gonna copy this URL right here, and then I'm gonna be able to actually kind of clone this entire repository to my machine. So what I can do now is I can kind of go in my command prompt here. This is different from the repository we've been working on before. So let me actually close this one, and I can navigate, say, to my desktop. So cd ... and then I can type git clone and the URL of the repository I want to clone. When I type this, it will likely take a second, but it will start taking all of the files from that remote repository and actually putting them in a folder called VS Code, which is on my desktop. All right, so now if I go to my desktop, I should see there's a folder called VS Code. There is a folder called VS Code, and it has all of that stuff from that remote repository that I just cloned. So I'm going to delete that one because I don't really care about that, but I was just showing you that is how you actually clone something. Now, when you clone a repository, by default, there is a remote setup that is called origin. So now if you make any changes to this repository on your machine and you want to actually change the remote repository, what you can do is you can push whatever branch it is that you've worked on or whatever changes it is that you've made directly to the remote repository just by typing git push origin and then the name of the branch that you want to push. You don't need to explicitly set the origin branch because when you clone a repository, the origin is this URL right here. And so it's already set for you. Anyways, I think that's all I wanted to cover for this video. If you guys have any questions, please feel free to leave them in the comments. If you enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in another YouTube video.